Okay, so today we're going to be talking about a new unit, or we're starting a new unit. And so this is going to be astronomy. And the very first thing that we're going to start it off with is the Big Bang. So the reason why the Big Bang is really important for this unit is because it basically tells us how the whole universe formed. And there are two major pieces of evidence for the Big Bang that they'll require you to know. So those two pieces of evidence are called redshifting and cosmic background radiation. So that's objective number one for today, knowing those two things. The second objective for today is that the Big Bang, as the current major theory goes, is the result is the creation of the universe. And so today, what we want to go over is we're going to start with like notes on there. Actually, before we even go into the notes, like everyone has this question, like how does the universe get here? And this is like a theological question also, and it's a science question. This is a science class, so we're going to approach this as if we're just scientists, not theologians. So I'm not a priest, I'm not your pastor. So the questions that we're going to be asked today and how we're going to answer them are non-religious in nature. This is just purely science, okay? So let's go to the notes section. So to get your full points in this notes section, you're going to have to go along with me. Basically, you're going to have to watch this video, and you're going to have to fill in the correct answers as I am saying them. So in the very first, on the top of this page, it says, according to the Big Bang Theory, the universe started up around, and that's 14 billion years ago. So that is crazy. That is an extremely long time. We actually have a hard time wrapping our minds around huge numbers like that because it's just so like out of our realm of experience. And so like to put that into perspective, the Earth is only like 4.5 billion years. So I'm going to turn this light on and then I'm going to show you guys this. Hold on, I drew it up here. So like if this is the Big Bang, so this is the creation of the universe. So 14 billion years went by to our present time over there. The Earth only formed over here, and we know the Earth is extremely old. So the universe is much older than even the Earth. And so can you see near our time, can you see a little red line like in there? I put that's the age of human existence. Can you see it at all? Actually, you can't. Like it's so small and so tiny, and it would be like so minuscule. Like we, in the long scheme of things, don't matter. Like we just, we've barely even been here. We're not the center of the universe. We're not the most important thing that's ever happened. So much has happened. We have no clue. A lot of it what's happened. There could be other species out here, other like extraterrestrial life, sentient life. We don't know yet. So that's what's crazy. That's why this is super exciting. Anyway, let's get back to the topic on today. So the next thing we're going to say on here, it says all the stuff in the universe was packed together in one dense point called a singularity. I know some of you maybe have heard like Singularity event. There's like some movies, sci-fi movies talk about singularities. So singularity is just one dense point, okay? So that's the third bullet point. It was real hot at first. And when I mean real hot, I mean 10,000 million degrees. So after things cooled down just a little bit, the first stars and galaxies began to form. So those are the next two things you're going to fill in. So stars and galaxies. So there was an astronomer, Edwin Hubble, discovered the first major evidence of the Big Bang. So his observation suggested that not only is everything in the galaxy moving away from everything else, but that all matter has taken the same amount of time to get where it is today. So starting out from a single position. So this is the 1, 2, 3. This is your fourth bullet point down. This is single position. So everything, as we know it, started at one little point, the singularity point, and then it exploded. Okay, so the next bullet point, it says later in the 1960s, up through the 1990s, several radio telescopes. So these are telescopes that don't use optics, so you're not like looking through them. They use radio waves. Provided even more concrete proof that the Big Bang Theory is correct. So, in fact, one telescope was able to look so far in the distant universe that it actually found leftovers of radiation given off by the Big Bang. So, this radiation is referred to as cosmic background radiation. So, those are your two things. The first one, leftovers of radiation given off by the Big Bang, and the next one is cosmic background radiation. So we're going to go on to the next part. It says Doppler effect and redshifting. Now, this is kind of hard to describe and to show without having videos or without me there drawing in front of you. So we're going to put a link to a good video along with this assignment, which you can watch along. But right now, I'm going to walk you through it. So it says, according to the video, which you guys are getting ready to watch, what color does an approaching, or what color does an object approaching the Earth have due to the compression of wavelengths? And this is blue, okay? This won't make any sense until you watch the video. So according to the video, what color does an object traveling away from Earth due to the expansion of wavelengths? That's red. So on here, this is a little bit of a physics type thing. You would learn that like visible light has wavelengths. So light travels like this, okay? So it has like a movement like this. It's not like a direct laser. It's not this like straight line. All light, all radiation travels with these wavelengths. The smaller the wavelength, the more intense, the more energy it has. So like gamma rays, they're very destructive. You can think of them as like being able to burrow through you, much easier. So visible light has much larger waves. Even some like radio waves have like waves that could be like 10 foot tall. Like I think even taller than that actually. So I'm going to show you like just a very quick example of red and blue radio waves. So if we look on here, let me put the light back on. So if we look back up here, we see the blue. So when a star is approaching, a star or a galaxy is approaching a human on Earth, it will look blue to us. But when a star is moving away from the Earth, it will look red to us. And it's because these waves of light get larger as it's moving away from us, which makes us perceive it as red. And then here, as this star is approaching Earth, these wavelengths compress, and so we see it as blue. Okay, so you guys are going to watch a video then that will give you a better example of that. But I want to talk about one more thing. So the next section is a close reading section, and in this we'll sort of talk about everything that I talked about already in this video, but I want to point out something. So there's the Doppler effect, which is about, you're going to read about this in a second. You've seen this before. Like you're in the city and you hear police cars come or an ambulance, and the siren sounds very different as it is far away from you, as you know, when it's approaching you, when it reaches you, and then finally when it goes away from you. It has almost like 3 different sound characteristics. And so that is a very good example of the Doppler effect, which has to do with the shifting of wavelengths, the size. The same thing that is happening there, that Doppler effect, happens with the visible light that comes off the galaxies and the stars that are either approaching us or flying away from us. So the next section that you're going to do in this is basically after the reading, you're going to go through and you're going to answer some simple questions, again, which is everything I just talked about. And you're going to start answering Regents prep questions. If you guys have any more questions, make sure that you turn in to my office hours. I'll be able to help you much more then.